relationship between resistance and resistivity. So, what relation you are going to say, means we are going to say that R is equal to rho L by this relationship only you are going to prove between the resistance and resistivity. How we obtain this equation? Yeah. So we all know resistance of the conducting material is directly proportional to the length. Resistance of the conducting material is directly proportional to the, like that, resistance of the conducting material is inversely proportional to area of cross section. Let's take this equation number. So now what we are going to do is we are going to compare equation number 1 and 2. What is equation number 1? R is directly proportional to length and inversely proportional to area of cross section. Here I don't have denominator. Let's assume it as 1. L into 1, L. So R is directly proportional to length. 1 into A. So now what we are going to do is we are going to remove this proportional symbol and we are going to introduce a constant term called as rho. Here the symbol what we'll be using, it's called as rho, and here the symbol represents resistivity. The symbol represents resistivity. So this resistivity we can also call it as specific resistance. Resistivity we can also call it as specific resistance. In exam and all they'll be using only this term. What is the unit of specific resistance? R. Define specific resistance. By the time don't leave that one. Specific resistance and resistivity both are same. If I need to calculate rho means how the formula will rearrange? Rho is equal to, here A is in division, while coming to the other side multiplication. Sorry, rho is equal to, right? Rho is equal to R into A. Here L is in multiplication, coming to the other side division. So rho is equal to R into A by L. So this is the formula what we'll be using in order to calculate the resistivity. So what is the formula? Rho is equal to R into A by L. Now, so what is mean by resistivity? It's defined as a resistance of the conducting material per unit length in a unit area of cross section. So each and every material will oppose the current. Whether all the material will oppose the same amount of current? No. How much it's going to oppose? If you are measuring that one, we'll be learning about the resistivity, and in general how we can define this one. Resistivity is defined as resistance of the conducting material per unit length in a unit area of cross section. And what is the formula to calculate resistivity? Rho is equal to R into A by L. Here rho stands for resistivity. R stands for resistance. A stands for area of cross section. L stands for length of the conducting material. So by using this only, we are going to derive the unit of resistivity. One of the important question. What is the unit of resistivity? The unit of resistivity is ohm meter. But they won't ask directly as it is. They will be asking us to derive this one. So from the formula only we are going to derive it. So what is the formula? Rho is equal to R into A by L. Already we learned the unit of resistance. What is the unit of resistance? Ohm. Area we learned in the lower class. What is the unit of area? Meter square. Length unit is meter. If you are substituting all the values over there. So rho is equal to ohm into meter square by meter. Meter square is nothing but called as meter into meter. For that we can cancel one square. Remaining what will be there? The unit of resistivity is ohm meter. So what is the unit of resistivity? Ohm meter. Next. On what factors does the resistivity of the conducting material depends upon? One is nature and another one is temperature. On what are the factors depends upon? Nature and temperature. And on what are the factors it does not depend upon? Does not depend upon the two factors. What are two factors does not depend upon? Length and the area of cross section. The resistivity does not depend upon the length and area of cross section. So let's take a condition. There are two wires are there which are made up of copper. In this, the first wire is going to have a length of 1 meter and second wire is going to have a length of 2 meter. And the area of cross section of the first wire is going to be 1 meter square and second wire is going to have area of cross section of 2 meter square. So like this they'll be asking the question and then they'll ask us to state about the or what will be the nature of the resistivity. The resistivity remains the same. Why? Because both the wires are made up of copper. Since the nature of both the wires are going to be same, the resistivity also is going to be same. Reason, it does not depend upon the length as well as the area of cross section. Whatever the values it may be given over there. If both the wires are made up of copper means the resistivity also is going to be same. Second condition. If one wire is made up of copper and other wire is made up of aluminium, let's take the value of the length that it is same 1 meter and here length is going to be 1 meter. Area of cross section is 1 meter square and area of cross section is 1 meter square. Here whether the resistivity will remain same or else it will vary. It will vary. Reason? The nature of two material is different. Since the nature is different, the resistivity also will vary. Next. So remember this one. By using the range of resistivity, we can divide the material into different categories. The range of resistivity is given in a form of 10 to the power of -8. The material is going to be in a form of a conductors. If it is going to be in a form of -6, it's going to be in a form of an alloy. So what is meant by alloys means? Alloys means a mixture of metals. A mixture of metals. And then if the range of resistivity is in a form of positive, that means if it is very high means by the time the material will be calling it as the insulator. You remember these two alone? Yeah? -8 means is going to be conductor and -6 means is going to be alloys. Next. So why do the heating element are made up of alloys rather than pure metal? Heating element means, for example, if you are taking the geyser, the conducting material is present inside the geyser is going to be the heating element. Not only this alone, even if you are taking the water heater, immersion water heater and all will be there. Clear? So in the end of the immersion water heater, a spring-like structure will be there. So this part of the this part is the right. We'll be calling this one as the alloys. And why heating element are made up of alloys and why not the metals means reason alloys does not oxidize. Oxidize in the sense it won't burn easily. Burn means it won't melt. When it is not going to melt, whenever the temperature is going to get increase. So that is the reason they are made using the alloys for a heating element. Next, the question is the resistance of a metal wire of length L is equal to how much meter again? 1 meter. So by the time, what is the resistance of the conducting material? 26 ohm. What is the resistance of the conducting material? 26 ohm. And if the diameter of the wire D is equal to 0.3 millimeter. So here millimeter is given. First what I need to do means we need to convert. So 0.3 into 10 to the power of -3. If we don't want this decimal means we can rearrange the same thing as 3 into 10 to the power of -4 meter. We calculated the diameter. And then what will be the resistivity of the conducting material? That's what you're going to find. So what is the formula? Rho is equal to R into A by L. So in the question, resistance is there, length is there, but area of cross section is not. First, let us calculate the area of cross section. So what is the formula to calculate area of cross section? A is equal to pi R square. In the given data, instead of R, they gave diameter. So we all know D is equal to 2R and R is equal to D by 2. So instead of this R, we are going to write it as D by 2. So A is equal to pi D by 2 the whole square. So A is equal to, what is the value of pi? 3.14 into, what is the value of D? Is 3 into 10 to the power of minus 4 by 2 the whole square. 3 is equal to 3.14 into 3 the whole square, 9. 10 to the power of minus 4 the whole square, 10 to the power of minus 8 by 2 the whole square, 4. So simplify, 2 2s are 4, 1 2s are balance 1, 5 2s are 10, remainder 1, 7 2s are 14. So multiply these two numbers, 1.57 into 9. 0.13. So this exponent we should not forget, okay? So into 10 to the power of minus 8 by 2. Now divide these two numbers. So A is equal to 7 2s are 14. Balance nothing is there. 0. 6 2s are 12. Remainder 1. 5. 7.065 into 10 to the power of minus 8 meters square. So what is the area we calculated? 7.065 into 10 to the power of minus 8 meters square. Now this value also we obtained. So now substitute in the formula. Rho is equal to, what is the value of R? 26 into 7.065 into 10 to the power of minus 8 by 1. Any number by 1? Same number. So then the numerator part is going to be 26 into 7.065 into 10 to the power of minus 8. So multiply the two numbers. What are two numbers we are having? 7065 into 18. Yeah, I think it's wrong. So what are the two numbers again? 26 into 7.065. Sorry. 26 into 7 point 7.065. 83.69 into 10 to the power of minus 8. So this one we can reduce into 1.8369 into 10 to the power of minus 6 ohm meter. 1.8369 into 10 to the power of minus 8 ohm meter. So clear. So the resistivity found like this. Clear. What is the resistivity? 1.8369. So this one we can also round off into 1.84 into 10 to the power of minus 6 ohm meter. So as per the given condition in this table, that means in the table 11.2, if you are identifying the values, it's going to be manganese. The given material is manganese. The given material is and next. Hey, based upon this one, you'll be getting at least 2 questions in all the exams, in the model exams. So listen carefully. A wire of given material having length L. If it doesn't know what is the value, let's take it as the length of the wire itself as L. And area of cross section is represented by the letter A. And what is the area of cross section is given? By that time, the resistance of the wire, how much it is given? 4 ohm. Next, what would be the resistance of another wire? Since we are taking 2 different wire, let's take it as A1, L1, R1 and L2, A2, R2. What would be the resistance of another wire of same material? Since both the wires are made up of same material, let's take the resistivity ρ1, ρ2 is equal to ρ. And then L2. What is the length of the wire it is given? L by 2. It's not 1 by 2, clear? Going to L by 2. So A2. What is the value of A2 is given? 2A. If it is like this means we are going to identify what is going to be the resistance. Clear? So what is the formula based upon this condition? R is equal to rho L by A. This is the general formula. So based upon the given condition, if I need to write means R1 is equal to rho 1 L1 by A1. So R1 is equal to what is the value of rho 1? Rho L1 L and A1 A. If this is the condition, when they said that the value of resistance R1 is going to be 4 ohm. That means if the rho L by A, it's going to be 4. Now we'll write for the second wire. What is the second wire? R2 is equal to rho 2 L2 by A2. So R2 is equal to what is the value of rho 2? Rho L2 L by 2. A2 2A. So this one it's in a form of complex fraction. Rearrange into our normal rho L by 2 into 1 by 2A. So rho L into 1, rho L by 2 into 2, 4A. So and this is the variable. So rho L by A it is nothing but called as 4. So instead of rho L by A, we can write it as R2 is equal to 1 by 4 times of 4. So 4 is by 4 cancel. Remaining what is in? R2 is equal to 1. So if there is, what is the resistance of the new wire? 1 ohm. Next. Why are the coils of electric heater and electric toaster are made up of alloys? Reason already said. What is the reason? Alloy do not or does not milk we should not write. What you need to write? Oxidize, or you can write it as burn. Easily at higher temperature. Clear? Next. So look at the tables of what is given in a textbook. In this the values are not clear. Which among iron and mercury is a better conductor? So the iron value is given 10. And mercury is over. The values are not clear. Let's refer the text. The resistivity of iron is given as 10 into 10 to the power of minus 8 ohm meter. This is for iron. And the resistivity of mercury is given as 94 into 10 to the power of minus 8 ohm meter. So in these two values, which one is having more resistivity? Either iron or mercury? Mercury. So here, the resistivity is high. If resistivity is high means resistance also will be high, current flow will be low. Here, the resistivity is less. So resistance will be less and current flow will be high. That means in these two, which is the best conductor? Iron is the better conductor. Which material is the best conductor in this given table? Check the values. Silver. In that given table, silver only is going to have very less resistivity compared to copper. The resistivity of silver is given as 1.60 into 10 to the power of minus 8 ohm meter. But we are not using silver. Why? Because it's economically high. The cost of silver it is high. That is the reason we are not using silver, even though it's having low resistance. That means even though it is the best conductor compared to copper.